Today we're going to look at infinite series. This is the last topic in the series and sequences section of the course, and this is a huge calculus topic. In fact, this is something that you discuss for probably 2 weeks in your second semester of calculus, and what we're doing here is instead of looking at the sum up to n of a sequence or a series, we look at s of infinity. And in calculus we say, what is the sum of n numbers as n goes to infinity? And this is the concept of limits, and we use that concept to talk about series in calculus. So this is one of those things you will use in the future. You don't have to focus too much on it now, because you will get a review lesson when you get to this in your calculus course in college, or even in high school, if your high school is lucky enough to teach a BC or IB calculus. So we have a series here, 1 plus 2 plus 4, most likely plus 8 plus 16. And we're going to solve something. So we're going to say, what is s of 5? Well, if we remember the formula, s of 5 is going to be a, which is 1, times the ratio to the n minus 1 over the ratio minus 1. So this is just going to be 2 to the 5 minus 1, which 2 to the 5, what is 2 to the 5? If you need a calculator, you can plug that in and get that it's 32 minus 1. So s of 5 is going to be 31. Now, what is s of 10? Well, this is just doing some shortcuts here. This is the same thing as 2 to the 10 minus 1. So this will be 1023. And s of 20 is going to be 2 to the 20 minus 1, which is something I do need a calculator for. And this is going to be, this is a big number, 1,048,575. So here's the question. What do you think s of infinity is? Well, this is technically 2 to the, that's terrible too, 2 to the infinity minus 1. So we can kind of see that, hey, it's going to be an incredibly large number, and it's going to keep going forever and ever and ever. So that would be correct. And you're saying, wait, hold on a second. All we're doing is multiplying by 2, and it's going to infinity. What's the use of this? That's a good question. That is a good question. Because there is a situation where this sum will exist as something that's not infinity. And there's a formula for this. S of infinity is equal to a over 1 minus r when the absolute value of r is less than 1. So what this means is that r has to be between -1 and 1, and it cannot equal -1, it cannot equal 1. So that is the condition on this. So the common ratio is less than 1, but greater than 0 point, or -1. And I'll show you something here. What is the infinite sum of 50 plus 40 plus 32, so on and so forth? So to find r, we take our second number, divide it by the first, and we get this is 4/5. Our a is going to be the first number, which is 50. And we can see here that the numbers are getting smaller as we go on. So if this goes on forever, eventually we're going to be adding like really small numbers, like plus 0 and plus 0, and they're going to be so small they're not going to make a difference. So clearly we should get some number, some finite number. So if we plug this into our formula here, our infinite sum is going to be 50 over 1 minus 4/5, which is the same thing as 50 over 1/5. And this is the same thing as saying 50 times 5, which is just 200 and 50. So the answer, the sum of this whole series that goes on forever and ever and never terminates, is 250. And what's really cool is with these, you can actually graph them pretty nicely. So with a sequence like this, or a series like this, we have an asymptote here, and it never quite reaches it. But we start at, say, 50. And then we go down to 40. So the sequence looks kind of like this. And we can see that the sequence keeps getting smaller and smaller. But the sum, what happens is, after the first one, it goes to 90, and then it'll go to 122. So the sum, or the series, will start to look like this. And it'll never ever quite reach 250, but it'll get very close. And that's a cool way that we can graph these geometric series. And you can see that if you keep getting smaller and smaller, you're going to get a result that looks like this. On the other hand, if the series increases in size, you get something that looks like this. And then it goes to infinity. Or maybe it'll go to negative infinity. So here's another question. What is the infinite sum of 9 plus 6 plus 4, so on and so forth? Well, our a is equal to 9. Our ratio is 6 over 9, which is equal to 2/3. So our infinite sum formula is going to be a over 1 minus r. This is a. So we have 9 over 1 minus 2/3, which is 9 over 1/3, which is just 9 times 3, which is equal to 27. So the infinite sum of this is just 27. And we can graph the same thing if we want. So here's a couple words for you. If the infinite sum is a number, then the series is convergent. So we just looked at two convergent examples. This series was equal to 27, so we say this series is convergent. And the one we looked at before is equal to 250, so this series is also convergent. Now, the main topic in calculus is really not solving for numbers, but saying, is it convergent or is it divergent? So divergent means that it goes to infinity or negative infinity. If it goes to one of those, it's divergent. So how can we tell if a series is divergent or convergent without even computing or calculating an answer? Well, we know that S infinity is equal to a over 1 minus r if the absolute value of r is less than 1. So let's take a look at some r values here. In the first one, 20 minus 10 plus 5, well, let's take the second term, divide it by the first term, and we get negative 1/2. Well, because the ratio, the absolute value, is less than 1, we know that the series is going to converge. We could solve for the number if we wanted to, but that's not what we're asking. In fact, we can just take a look here. Are the numbers getting smaller in size? And if the answer is yes, then the series converges. What about 1 plus 1 plus 1 plus... keeps going on, we're just adding 1. Is it convergent or divergent? Well, we have 1 divided by 1, which is equal to 1, and the absolute value of 1 is not less than 1. So the series diverges. Why? Because if we keep adding 1 an infinite amount of times, we're just going to reach infinity. We're going to keep going higher and higher and higher. So it's going to diverge. What about 1 plus 99 over 100 plus 99 squared over 100 squared, so on and so forth? Well, we see that we're actually just multiplying by 99 over 100 every single time. And is 99 over 100 less than 1? And the answer to that is yes, of course it is. So, this series is going to be convergent. It's going to converge to some number that is not infinity or negative infinity. So this is how we test for divergence and convergence. We have one more thing we can do here, just for some formula play. Instead of solving for the sum, we're going to be given a sum, and we're going to be given an a value, or a starting value, and we're going to say, what is r? So, s infinity is equal to a over 1 minus r. So we have 36 is equal to 54 over 1 minus r. Now here's an interesting thing. The sum is less than the first term. So you're saying, hold on a second, this is impossible. We have a sum that's smaller than a first term. Well, what this really means is that the series is probably alternating, which means it's positive, negative, so on and so forth. So let's do some math here. Let's multiply both sides by 1 minus r. So we're going to get 36 times 1 minus r is equal to 54. So when we expand, we get 36 minus 36r is equal to 54. Let's take the 36 over to the right side. So we get negative 36r is going to be equal to 18. And we divide by negative 36. And we find that r is equal to negative 1/2. So let's take a look at this. Our series is going to look like 54 minus 27. It seems to be this part of the screen. It doesn't work very well. Plus 13.5 minus 6.750, and it's going to keep alternating. And this series adds up to 36. And I kind of like this graph, because when you graph a series like this, if we take the sum, so our first term is 54, it's going to start here, and this will be our sum. So when we take away 27, it's going to go down to here. And then we're going to add 13.5. So it's going to move up to 40.5 here. Then we're going to subtract 6.75. So we end up around 33. And it's going to keep jumping back and forth until it gets to 36. And alternating series are pretty cool like that. So that's a nice little graph of an alternating series, and that is going to be it for the series and sequences. So you've now learned everything you need to do a chapter test. Of course, there's going to be a review video, because I think reviews are good. It's going to have a bunch of practice problems, and then in class you will have a test. I might make up a test and upload it to the website at TrevTutor.com. If I feel like doing that and that might benefit, I might upload a test and an answer key, so you can do that in your own spare time and see if you get things right as a practice. But if not, it'll probably be done in some time. Not sure when. Might be a year from now, 2 years from now. Might be up when you're watching this, who knows. But that'll be it. So expect a review video soon, and if you have any questions, as always, leave them in the comments below, and I will answer them as best as I can.